Your GPU has 6 gigabytes of VRAM sitting right on the card. Your PC probably has way more system RAM than that. So why can't the GPU just borrow some of that instead? The answer comes down to two things: where that memory physically sits and how fast it can actually move data. Let's start with location. Your CPU and system RAM live inches apart, connected across the motherboard. Your GPU is different. VRAM chips are soldered directly onto the graphics card itself, sitting millimeters from the GPU die. That physical closeness isn't just neat packaging. It's what makes short, extremely fast connections between the GPU and its memory possible in the first place. Here's the real reason VRAM exists as a separate thing at all: bandwidth. Typical system RAM moves data at around 50 gigabytes per second. The GDDR6 VRAM on a GTX 1660 Super, the exact card I use, moves data at 336 gigabytes per second. That's roughly 6 to 7 times more bandwidth than ordinary system RAM. So why is VRAM so much faster? Think of a memory bus like lanes on a highway. System RAM typically runs on a 64-bit channel per stick, a handful of lanes moving data each clock cycle. My GPU's VRAM runs on a 192-bit bus, 3 times as many lanes, all moving data in parallel every single cycle. More lanes moving data simultaneously means more total bandwidth, even before you factor in GDDR6 running at a higher clock speed than typical system RAM. So what's actually stored in that 6 gigabytes? A few things. The frame buffer, which is literally what's being displayed on your screen right now. Textures, the surface detail wrapped onto 3D objects in games. Shaders and compute buffers, the GPU's program instructions and working data while it's calculating something. And if you're running a local AI model, like I showed in an earlier video, the model's weights themselves live here too, competing for the exact same limited space. Now here's the part that trips people up. If VRAM is so fast, why can't you just move data between system RAM and VRAM constantly without a performance hit? Because the connection between them, PCIe, is the slowest link in the entire chain. On a typical PCIe 3.0x16 connection, you're looking at around 16 gigabytes per second. Compare that to VRAM's 336 gigabytes per second, or even system RAM's 50. PCIe is the narrowest bridge in the whole system, and every time data has to cross from system RAM into VRAM or back, it's forced through that narrow point. This is exactly why keeping data resident in VRAM matters so much for performance, whether that's game textures staying loaded instead of streaming in constantly, or an AI model's weights staying loaded rather than being reloaded from system RAM every time you send a prompt. Crossing that PCIe bridge is expensive, so good software tries to avoid doing it more than it has to. So to recap, VRAM sits physically next to the GPU die, using a much wider memory bus than typical system RAM, which is why my card's VRAM hits 336 gigabytes per second compared to roughly 50 for system RAM. It holds the frame buffer, textures, shader data, and model weights. And PCIe, at around 16 gigabytes per second, is the bottleneck standing between the two, which is exactly why your GPU can't just borrow your system RAM without a real cost.